So today we are finally going to learn joins, which are probably the most important things about relational databases. So the reason why it's so important is because we've been only working with one table at a time so far, right? And with joins, you can actually work with multiple tables at once. And usually that's where the insights come from trying to find relationships between multiple data sources. Like for example, stock traders back in the days, they joined the weather data source and also oil prices data source. And then that is how they discovered that you can actually predict oil prices using weather. So this is where the creativity comes in, and join allows for near infinite possibilities of working with data sets to get you the insights you need. Previously, we always did select star from a single table, and then we would do something to that table. What if you want to get data from multiple tables, join them together, and then get something that no one has ever seen before? That is the power of joins. Okay, so how do we work with multiple tables? Usually, you do it by joining them, because there are usually relationships between two tables. That's why SQL is for relational databases, because tables relate to one another. So you might ask yourself, okay, well, why do we need to join multiple tables? Why can't we just store everything in one table so we don't need to join multiple tables? Well, there's two reasons. The first one is that the people who created these data sets have no idea how you're going to use it. They don't know the infinite possibility of joining different data sets together. And then the second reason, most importantly, is that computationally, it wouldn't make sense to have large tables that contain all information. Like imagine if you had one single table that has all the information of the world. That doesn't make any sense, right? Like you need some order to it, and also computationally, it'll never work. And here's a perfect example. So here I have a table. It tries to encapsulate everything. Now note that these are toy examples. In real examples, they're a lot larger and requires a lot of resources to change certain things. Okay, so for example here, we have a table. Each row is a transaction. As you can see, the payment, and then you have restaurant ID, which means which restaurant it is, and then the name of the restaurant, the type of the restaurant, the number of employees in the restaurant, and then you have these customers. They're all represented by IDs and how much they paid the restaurant for whatever services that they gave them. Probably food. Let's pretend that this is a huge table of billions of rows, okay? Billions of transactions, thousands of restaurants. What would happen if we want to change the name? Then we would have to modify every row, potentially millions of rows. And that would be quite inefficient, especially if there are multiple restaurants changing their names constantly. I know they don't change their names that much, but let's think about employees, for example. What if just every day you have like a new employee joining McMickey? Look at that. Every time you would have to modify these rows. And if we change the name McMickey to McDickey or something, you're gonna have to modify all of these rows to have the name McDickey. So that's pretty inefficient, right? So what would be easier would be if there are separate tables. One table for the transaction, as you can see, just restaurant ID, customer ID, and payment. Every transaction is noted here. And then the second table is more of a dimension table, meaning that it only has the information necessary for restaurants. No transaction, each row is a restaurant, and here each row is a transaction. So now, if you want to change the name, you don't need to change millions of rows. You literally change one row, which is the single row in the restaurant table. All right, now that I've convinced you the importance of joins and separating tables, how do we join tables in SQL? Well, here's an example. So it's kind of similar to what we've seen before. Let's imagine that we are using these two tables again. This one is called fast food restaurants. This one is called transactions, fast food. Okay. So as you can see, there are a new few keywords here. Notice that there are also A and B. You might not have seen this before, but it's quite similar to what you see here as revenue. So this is basically an alias. Instead of rewriting my whole table name, I give it an alias A, which I will use in the future, right here, A. And B, right here. So instead of writing food.fastfood.id to select the column, I could just do a.id, just a lot faster. And it's gonna be pretty useful if ever you do joins, because you don't want to write a long line just for the table name. So the join keywords tells SQL to join the original table, which is fast food, indicated by from, and then on tells you how to join these two tables. So original table is fast food. The table that you want to join is food transaction. And then on tells you how you want to, or like what the rule is to join the rows. In this case, we want to join them via ID. So that means we want the ID of fast food to be the same as the ID of restaurant ID in the transaction table. So if we look at here, what's gonna happen is we're gonna join this row to this one, that one, that one. Basically all the transaction that has restaurant ID of 1, right? And then you're gonna be duplicating that. So essentially it would look like this table. Just ignore the yellow lines, but it would look like this table. As you can see, these are repeated. The restaurant ID, name, type, employees, these are repeated. And then same thing with Burger Queen, but instead of the 1s, you attach to the 2s. Quite simple. So technically, when you do joins, you don't need to have the on keyword, but it's not gonna be that useful. So without the on keyword, there's no restrictions. So that means it will become a cross product, which means that every row of the fast food table will be joined by the transaction rows. So that means in our example, it will yield 18 rows because we have 2 rows here, and 1, 2, 3, 4, 5, 6, 7, 8, 9, and 9 rows. So each row will be attached to all of them, and then you'll duplicate another one because for restaurant number 2, you're gonna get attached to all of these rows. So 2 times 9 equals 18 rows. So it's just gonna be like a long ass table. But then if you add this line, then you're gonna get a table that's similar to this because the restaurant IDs will be joined with the transactions that have the same restaurant IDs. Let me just fix one thing here. Let's call it ID instead, just to keep it consistent with this. Let's go back to our query. So what this query does is first, it joins the two tables together. So now the ID of the first table will be joined with the restaurant ID of the second table. And then we aggregate all of that by grouping by ID. So each restaurant will be one row, and then we will sum all the payments that happen in transactions to get the total revenue of each restaurant. So now that you know how to use joins, let's try it out on mode. All right, so today we are going to be using 2 tables, which is, let's see, Excel SQL inventory data. Let's look at this first. And we are also using the transaction data, right? So inventory, what it is you get a product, the product name, the product type, the units, and then price per unit, wholesale, and also current inventory. We only care about the price unit and product name and product ID. So basically, it tells you all of the things that this store can sell. There's not a lot of documentation, so I'm not sure 100% what this means, but let's just say we own a grocery store, and these are all the products that they sell and how much inventory they have. And then on this table, we have transactions. So there's a transaction ID. So each person is, let's just say, in transaction ID, and then which product they bought. Not a lot of documentation here, so kind of hard to infer, but let's just say that each time it's a row, they bought the product 1 time. All right, let's just say that. So for example, this person bought product number 3 and product number 61 once each. And then this second transaction bought 23 once. So this is kind of hard to read because you don't know what product it is, right? But remember last time when you separated transactions and fast food restaurants, is the same idea. So let's do the questions. Join the Excel SQL inventory data with Excel SQL transaction data. All right, sounds easy enough. So remember what we did? We select from this table. Let's call it A. So we gave it an alias. Oops. And then we want to join this table. And then we'll call it B. And then what we want to join on is the product ID because we want to get more information about this product within this transaction. All right, so join A dot product ID equals B dot product ID. And then we can erase that. Let's see what this looks like. Let's see if it works. Okay, looks like there's an error. So why is there an error? Let's read it. Syntax error at near A. Okay. Aha, it's because we forgot the on keyword. So don't forget, whenever you join and then you want to join with a rule, you have to specify by using on. This is the same thing as almost the same thing as a where clause, right? Where you can add multiple constraints and stuff like that. But most of the time, the most common way you join a table is with one single column. All right. So now that we got that, let's run it again, see what the rows look like now. So as you can see, I still have select star. So what star does is it gives you all the columns, right? But this time we have two tables. So we're gonna get columns from both tables together. So as you can see, these three columns, you remember them? They are from Excel SQL transaction data. You got transaction ID, time, and product ID. And then all of the rest is from inventory data. As you can see, product ID, name, product type, unit, etc., etc. So as you can see, it says duplicated column name 1, right? For this version of SQL, it's great because they would rename it to something else. But remember, you cannot have two columns of the same name because you can't do that. So what they did is they took the liberty of naming one of our duplicate columns to something else so that we can fit it all in our table. Now we have every single column from both tables. All right. So let's answer the next question. Which product sold the most in terms of quantity? So as we said before, every row in this transaction table is a single purchase. So let's just say it's a single purchase. So what we would do is we would do the same thing. We would join these tables together. So join on. And then what we want to do is we want to group by product name, right? And then so we'll group by 1. And then what you want to do is literally just count all the rows because every row is a transaction. And let's count. Let's see, what's the most popular item? Celery foam. Oh, that looks wrong because they're not ordered. I forgot to order. Order by 2 descending. Why do we order by 2? Because that's the count as number of transactions. All right. Oh, interesting. So the most popular product is olive tapenade. Am I saying right? Okay. And then the second most popular item is vegetable gyozas. I can totally see why. It's extremely delicious. All right. So there you go. You get all of these products and their number of transactions. Okay. What about which product made the most money? Okay. So what we can do, we'll just copy this query for now. But remember, in inventory data, there is a price unit. Let's use that. Let's say that's how much it costs. So that means what we can do is instead of counting the rows, we could sum the price unit, which is great because we couldn't do it before with transaction. Because with just the transaction table, technically you can order the products by how many times people bought it, but it would only be a product ID. But technically you could still know which product sold the most. But you definitely cannot get the product that made the most money because on the transaction data, you don't have a price. But now we do because we joined this table to the inventory table. All right. So now instead of num transaction, it would be like maybe revenue. So we sum the price unit, perfect. And then let's do it again. All right, excellent. So it seems like smoked trout and smoked salmon and frozen salmon, they made the most money, which makes sense. They cost a lot. So yeah, okay. So smoked trout, awesome. Was there a product that had no transactions? How can we figure that out? One thing about joins, and I'll talk more about that in the next class. If ever you're joining two tables on one column, what happens when one of the rows do not have a matching row from the other table? Well, they simply get dropped. So that's the trick here. All right, let's look at the quantities again. We'll select this, we'll run it. And as you can see, if you go all the way down, there isn't a single product that had 0 transactions. So why is that? It's because if there are no joins possible, then it just completely drops it. So that means if there was a product that had no transactions, it will not be shown here. It won't have a transaction number of 0. Okay. So how would you find a product that had no transaction? So what we can do is select star from the inventory data, which contains all products, but we only want the row that is not in the transaction data, meaning no one bought it. So where product ID is not in, actually that's English, that's not SQL, not in, select product ID of transaction. All right, let me just do this. It makes it easier to read. So as you can see, I am selecting a row where its product ID is not in this table, the transaction table, meaning that it had 0 transactions. So let's try this out. Let's see if there are products. There are products. There's one single product that had no sales, which is a cranberry milk, which makes a lot of sense because that sounds disgusting. So there you go. You have a product that had no transactions. So there's one last thing I want to show you is I want to show you a visualization. What happens when there are rows in one table that don't get matched on the table that you're joining? Then we just drop them. But I want to show you visually what that looks like. So here we have, let's say, 2 tables, users and likes, right? The users, you have their IDs, and in likes, you have a user ID listed here and what they like. So for example, Patrick likes coding and climbing, and Albert likes apparently nothing. Maria likes stars, right? So what happens when you join? This is what happens. So if you want to join these 2 tables, all right, so you're going to get these columns, name, ID, UID, and name. And name would probably be duplicated. Actually, no, it will not be duplicated, but it will have another column name, but this name is the likes name, and then this name is the actual username. All right, so first we have Patrick. So what's going to happen? We're going to join these 2 rows, climbing and coding, and then because there are multiple rows, then we're going to duplicate this. All right, so now we have 2 rows. Patrick likes climbing and Patrick likes coding. And then Albert likes nothing, so we're going to ignore him. So then we are going to get Maria likes stars, Darwin likes apples, and then that's it. As you can see, this is what join does. If ever you don't have a match from users to likes, for example, Albert likes nothing, and then also rugby, user number 6 likes rugby, but we don't have a user 6 here. And also user number 5, Elizabeth, doesn't like anything, and then they're just going to get dropped. You will not get these rows anywhere. So what if you want to keep Albert here and just have nothing on what they like because you still want to know all of the users that exist? Well, that's for next class. We're going to be learning about different types of joins. All right, that's it for now, and I'll see you next time.